right, just checking my microphone. Hopefully, oh, I'm gonna pull up the headphones. All right, recording. Hi. All right, just want to make sure my microphone works. Let me know if you don't see something properly here. I'm going to start sharing my screen, and we're going to share screen number 2. All right, my chat. Hi, Andrew. All right, so there's a fair number. How many of us are there right now? Let's see, 3 participants. Rip roaring time. I think people are going to join hopefully soon. Let me know if there's a particular questions you have when it comes to this, either this assignment or when it comes to loops. This week we're talking about loops. I'll go over examples of that if you want. But on top of that, if you don't want to deal with loops, we can do other stuff. So we can deal with, well, we're going to also deal with some arrays. And I want to see if you guys understand what conditionals are like. So what is a conditional for? So would you guys want help with the assignment, or do you want help with just the next concept on the coming down the line? Coming down the pike, by the way, is the proper term. I think it actually derives from the state of Massachusetts, where they, well, no, the state of Massachusetts still uses the word pike for road. But all right, nothing. Okay, how about this? Post your questions as we go. I'm leaving the chat window open, and I'm just going to start talking about. Let's just talk about arrays and for loops and while loops and all sorts of fun stuff like that. So let's get going. I'm going to suggest we're going to do the following. I'm going to look at, well, first of all, if you want to talk about conditionals and pointers, the only reason we need a pointer, you can just memorize what, or do exactly what I told you to do for the assignment. You don't even need to know what a pointer is. It was those strings, that text that we were dealing with. And also when we deal with an array, and it looks weird, and it is weird, but I can go over that in a bit more. And then I'm going to look at, I'm going to make an array. I'm going to pass an array into a function. In fact, I'm going to try and help for, I think it's even A8. I think A6 also deals with this. We're going to get the median of a bunch of values. Well, whatever. Why not? Okay, so we're not going to do it exactly the way that we're going to do on the on assignment 6, but we're going to do something interesting. So the median is the center point. We're also going to assume, incorrectly, but we're going to assume that our median is we have an odd, either have an odd number, or the median, we're just going to choose the if we have like 4 numbers, we're going to choose item number 2, not item number 3, not the average of item number 2 and 3, right? If we have 4 items, I'm going to go, let's come from 0. 0, 1, 2, 3. All right. I'm going to go and return value. If they're in order, the value here, right? 0, 1, value 1. Normally for an odd even number, I would average these 2, and that's what my median value would be. But this time, I'm just going to say this one. Now, if I have 5, it's easy. It's my middle finger, right? It's the middle value. That's what the median of a bunch of values is. It's not the average. That's one type of average. It's not the mean, the median. It's the center point. Okay, so that's what we're going to do. And that's because we don't have that in an assignment. And then I'm going to try and get angry text. I'm going to take some kind, I don't know if I already have that in assignments, but I'm going to take in an array of characters, and I'm going to convert all the characters to uppercase to pretend I'm yelling. Why not? Okay, we'll also get to do with conditionals on that point. Actually, we're going to hit conditionals in all sorts of different ways here. So let's make an array of, let's do, first things first, let's make an array. So, and again, this is under, let me see here, I think it's sync6. It's in the in-class code in the synchronous lectures, synchronous lecture 6. It's not actually number 6, but I don't know what number it is. All right, so I'm going to make an array. Let's make an array of integers. Okay, so I'm going to have an int. I like putting the A underscore is not mandatory. I like saying like, it's an array. Hello, it's an array, because otherwise I'll forget. In fact, this is actually a regular problem with C++ and C, and that's the reason that they made this convention. You can't tell if something's just pointing to a value or if it's a whole other array, and so making the name meaningful can help. Um, but let's see here. Find median. So it's an array of values for my function find median or median. Okay. And normally what I could do is something like this. And so this is going to be an array. That's what that square brackets is. There are a bunch of boxes that are going to put stuff in. And then I'm going to put some values in here. So let's put 4. That would be zoom, saving my file. Okay. For 17, negative 17, 33, 9. Some random set of values. Now, I could count this up and go 1, 2, 3, 4, 5, put the number 5 in here. Just to be very explicit, I have 5 values. Or I could leave it off and I will have a size 5. But if I put a 5 in here and I add another value in here, look what happens. 11. That should yell at me. There we go. What's this yelling at me for? Too many initialized values. I get some kind of error. That's the one advantage of explicitly putting the number here and putting the values in here. So this will make an array starting up with the values 4, 17, negative 17, 33, and 9 in it. Just a bunch of numbers, one after the other. That's what an array is. Okay. I need to figure out what the size of this thing is. Let's do this as well. Constant int fm size, find medium size, and we're going to make that equal to 5. Start off. So I'm going to use this value in a second. All right. I'm not really going to do anything with this. In fact, I'm just going to call a function. In fact, I got to think through this. Finding the median of a value is actually a lot harder than it might seem. Because how do I know where the middle point of this thing is? How would you figure out what the middle point of this thing is? So, any suggestions, actually? We could try a bunch of different things. I have something in my head, but and I'm just going to put, I know what my function has to be looking like. So, oh, I also want to return. How would you, and I have enough people here that somebody should answer, how would you find the median? If I have those numbers, 4, 17, negative 17, 33, and 9, how do you find the median, the middle point? So in this case, what would the value be? It would be 9. The first value is negative 17. The next value is 4. So I put it in order. 4, 9, 17, 33. Do we have a message? No, we don't. In order, that's what it would be. And so the middle point is right here. Now, there's a bunch of things I could do. One of those things is I could sort it. That would be perfectly fine. Turns out sorting is one of those standard things that we love doing. It's one of our, bread and butter tactics as programmers. That is perhaps one of the best solutions you could do. You would just sort this thing and I have some kind of sorting algorithm, and then, which we're not going to do, but we could do that. In fact, it would be a perfectly fine approach to do that. So I could sort everything, and then I could just find the middle point halfway and return that value. What other things could I do? You guys aren't participating. So I have a bunch of numbers. It may not be 5 numbers. It might be 17 different numbers. It might be 400,000 numbers. You have no idea what this array looks like. The function has no idea what this array looks like. It has to work a thing to find the median, a function to find the median. Look, if I'm using Excel, that function's in Excel, for example, it does not know what the user's data is. You give it any kind of data, it finds the median value for you. That's what we're looking for. We want these functions that can do whatever the input you throw at it, it handles. The median takes in whatever input you give it, and it finds the median point. That's the point, right? We don't want these custom-made one-off things. We want a function that can be applied in a whole bunch of different ways, like we did previously, like we're doing in your miscellaneous functions, which I think is this week's lab, this week's assignment, right? With the Super Bowl printer and all that kind of stuff. So how would I do this? Well, one of the approaches I could take is to have a sorting function. So I sort the array, and then after I've sorted the array, what I'm going to do is I'm just going to swap, I'm just going to find the middle point. What other things could I do? So I'm going to have a weird case up here. I'm going to need to make a brand new array of this size. And I'm going to need to, then going to have to copy everything over. In an ideal world, this is what I need to do. I need to break a brand new array, copy everything over, just so I'm not modifying this thing. But I'm going to modify this one. I'm just going to straight up modify. I'm allowed to I can actually modify my array in the function, which is weird. And it's weird because of this thing right here. All I've said, the way I'm passing information, the way I'm passing a giant big array from the main to over here, is I just say where it's located. That's what we're going to get to pointers. We'll see this again. So instead of copying all of this information over, like me moving my house down the street, instead I just say, I live over there. I give them my address. I don't have to move stuff around. I'm saying where it's located. The array, all of these numbers are located over there. That's what I've done here. This is the location for where all of these numbers here, the location of these numbers. And now I can move stuff around in this array, this chunk of different numbers. I can move stuff around in that array within this function. It gets dangerous. I can actually change this array here by just moving stuff around in the function. Okay. Here's my plan of attack because nobody's responding at all. At least I can't see anything. I have one high and that's it. One of the other approaches I could take is I could find the minimum element in my array. And what if I take the minimum element of my array and just put it down on the far end? Mute my. So I find the minimum element of my array, and then I move it to where this position here. So instead of 17, 33, 9, I get 9, 33, 17, negative 17. And then I pretend I only have 4 elements in my array. Then I get the minimum element of that thing, and that would be the 4. And I move it to the end, and then I swap the 33 and the 4. And so I'm just going to shrink my array and move the smallest value over the far end. The only reason I'm doing this is because I need to put it somewhere where I know I'm not going to screw something up. I could find the minimum value, put it at the front, and keep doing that and do that for the entire. Let's actually do that. We're going to find the minimum value in my array, and put it at the front. Will that work? No, I don't want to do that. I want to just say, I want to do what I was doing before. It's going to get really convoluted with pointers otherwise. So I'm going to take my array. Every time I find the smallest value, I'm going to put that value at the end, swap it with the very last element, and then pretend my array is smaller. With me so far? I'm going to need to do that a bunch of times, but I'm also going to need a min index function. So unsigned int min idx. I'm hoping that's not an answer in your assignment, but if it is, notice I don't know how big my array is. That's why I need to keep on passing in the size of the array. There's nothing in the array itself that it's just the location. It doesn't, if I give you my address, it doesn't tell you if it's an apartment building, a house, a duplex, if it's I live in a factory, if I live on a diaper barge, whatever the case is. Yes, that was a big mouth reference. Right? You don't know where I'm living. You just have an address. And therefore, I need to say how big this thing is, how big this array is. And we're going to take that, use that to our advantage. Okay, so here's me doing the min index. I need to walk down my entire array, find the smallest value, the minimum value, return the location, the index of that. Was it position 0, position 1, position 2? That's what I'm doing. Return the index. Now, what I could do, let's change it up a bit. I'm going to be int. Why? Because what I'm going to do instead of this, I'm actually going to return -1 if it's not in the array. If the array is empty, for example. Just bad crap happened, return -1. This is a nice way of thinking about things. Okay, so if conditional a nums is equal to null, we're going to be talking about null soon enough, but this is if there's nothing there, equal to 0 technically, then I'm going to return -1. Okay. If there is something there, or conditional statements, a size is equal to 0. Right. Otherwise, I'm going to have a for loop. I don't even, again, I'll point out, I don't even think when I have a for loop. I always make my for loops the exact same way. And you might say, but why would you do that? And I say, because I don't want to think. I sometimes will do that. That's the one difference I'll make because I need to compare a size. As long as it's less than the size of my array. So the size of my array is 5, 0, 1, 2, 3, 4, stop. That's why I do it this way. So I don't have to think about it. I start at 0, go to there, done. It's always up to, but not including that value. That's nice and memorized. Okay, so I have a for loop. I'm going to go through my for loop and I'm going to check, I need to keep track of the index of the smallest value. So unsigned int. I'm going to set to 0 to start because if there's nothing in there, I can stop after 1. Okay. I could also start I at 1 if I wanted to. That would be perfectly fair, perfectly fine. Right? I don't know. If I have an array of size 1, the first one is the smallest number. It's also the largest, right? There's only one thing in this array, in this list of numbers. The first element is the biggest, the smallest, the medium, it's everything. Okay. But I want to check to see if a nums at min index at this location. So right now it's 0. If that is greater than a nums at the current location I'm looking at right now, So every time through this loop, I becomes 0, 1, 2, 3, 4, 5, 6. If I find a number that's smaller, so if I find a number that's smaller than what I currently store as the minimum, min idx is equal to I. So I can type. All right, done. First time through the loop, I compare 0 to 0, position 0 to position 0. That's fine. It's one extra step, but who cares? Next time, I check position 1 to position 0. Okay, position 2 to position 0. And I would take one of these numbers and see for myself how this works. So it starts off with the value is 0. This is the smallest I've seen so far. I get here. Smallest I've seen so far is, oh, still here. When I get here, smallest I've seen so far, oh, this is new. I go into this if statement and I change. So the index of where I'm looking, the minimum index, is now 2. 0, 1, 2. Okay, that is now a new minimum index. Is 17 less than 33? Yeah, it sure is. Is negative 17 less than 9? Yeah, it sure is. And then I return the index, the location of the negative 17, which is position 2. This thing will return 2 the first time when I call this. I'm missing a closing parentheses. Okay, that's all this min index does. So what I could do, if I want to make sure my thing is working, I could assert, let's say, let's see, an index of a find median and FM size. I'm going to say that that's got to be equal to 2. I need to also include asserts. No, we got a failure. All right, that's fine. That's something wrong here. That's fine. Missing closing paren here. And this thing has to return some value, return 0. Man, there we go. And then I just check my code to see it's working. Hey, it worked. Nothing blew up. Okay. Next up. So that's all I wanted to do for the first part. Now I'm going to find the minimum value, swap it with with whatever my last one is, shrink the size of my array. Over and over and over again. Okay. And so I'm going to just keep on removing the smallest value until I get to some endpoint. So I want to make sure, I want to see how many times I've removed the last value. Okay. And num removed. All right. I have the size, I have the number of elements I've removed. I'm just going to keep on calling. So we're going to do a while loop in this case. I want to see while a size minus no, greater than, and then this would be the size, the number, the median point is the size of my array, so 5, let's say, divided by 2, 2.5, but integer arithmetic becomes 2. This could be wrong, but I'm going to check out my math in a second when I test this. If I have a while loop, I better make darn sure that this thing will actually stop. The only way to make this thing stop is I need to make sure that the number of removed increases every single time. The only way that this is going to work. I also need to make sure that the a size is greater than 0, even greater than 1, actually. A size is a size divided by 2. So if it was 1, this is 1, it's not going to do anything. If it was 2, it's going to return the first element. If it's 3, I need to remove at least one element. Okay, that should be fine. Hopefully. We'll find out. Okay, remove half the elements, then return the min. So I'm going to call this return min index thing. Index of them. We're going to return the median index. Maybe I should call it median index everywhere. I'm just trying to, I'm exploring the idea. Okay. So if a nums is equal to null, or a size is equal to 0, return 1. There's nothing there. I'm going to remove half the elements each and every time. And then I want to call return. At the end, when I'm done with all this stuff, I'm going to return, I'm going to call return min index a nums, and oh, my size here is a size minus num removed. That should, I'm hoping, we'll find out. All right. I'm more than happy to. I was waiting for people to ask for questions like that. Oh, let's see if I can do a Ternary operator here. Oh, let's do a ternary operator right here. That should. All right, ternary operator. Min index is equal. It normally is only for assigning some value. I'm not doing a whole bunch of logic. I'm doing like one thing. So in this case, I'm setting my min index. Min index is equal to, and now I have some kind of test, which is going to be this thing right here. Done. Question mark. So if this is true, do this. If it's not true, do the other thing. Okay, so if this is true, I'm going to say min index, sorry, it's going to be I. If it's true, min index is going to be set to I. Otherwise, well, it's just going to be min index. Don't change it at all. Now, I think I can even leave off that colon if I wanted to, but I'm going to put it in there. So this should be doing the exact same thing as the other one. I do a test. If it's true, do this. I'll do one other part of it, which is going to be else. Here's what it looks like. The whole thing converted over. This is this thing right here, commented out, is exactly identical to this thing right here. Set min index, depending on this condition, if this is greater than this, then I'm going to change I. Otherwise, I'm going to keep the value the same. And you got to play with these a bunch of times just to get, because I avoided ternary operators for years and years and years. In fact, I didn't write them really until I started teaching this class. It's when I don't find them that intuitive. Okay. So I've already got myself into a bad situation. So let me point out what my bad situation is. My bad situation is if I write a while loop, the first thing I should do is find a way to close it to make sure I don't have an infinite loop. It's bad news if I have an infinite loop. So what I might want to do, how do I make this thing stop? if I keep on increasing, I can either shrink a size, makes it equal to this. I can, no, actually won't. That won't necessarily close it. It might eventually. It'll become a negative value. Yeah. So I could shrink a size. But the more logical thing here is I'm going to keep on increasing number removed. And so that number here is going to get smaller and smaller and smaller. A size divided by 2 stays the same. And eventually I'll stop. Number removed is equal to number removed plus 1. That's the shortcut version of it. Okay. This is guaranteed to stop. It's not going to do anything, but is guaranteed to stop. And then afterwards, I'm going to find the minimum element that I have left in my array. But notice it's because I'm putting the smallest elements at the very end of my array, so this thing keeps on shrinking down. I'm also going to keep on calling this over and over again. So this is my plan. I'm going to get I'm going to find out the minimum index. No, that's not what I want. That right. And I'm going to get the smallest value. Then I'm going to swap it with the last element in my array. So so it's a nums at here's me swapping 2 numbers. I need an intermediary value. I need a value in between. So a nums is equal to a nums at position a size minus right. This position just keeps this position keeps on moving over. The other position stays the same. I find the minimum value. This is my let's make a new value for it. Last index value is equal to this. All right. So this is me finding the last element of my array because I'm going to pretend the rest of the elements of my array are not there anymore. And then all I'm going to do is swap those things around. So I got to do the last part of my swap. Oh, come on, caps lock on. So I'm swapping 2 numbers around. After I find the minimum index, I swap 2 numbers around. Then I'm going to increase. I'm going to remove that last element by pretending I have 1 fewer element in my array. So I go from 5 to 4 to 3 to 2 to 1 to 0. Okay. So I'm going to keep on doing this until I'm halfway. And then I'm going to return what the minimum value is. And I could be wrong all sorts of different ways in this case. So I want to see what I'm doing wrong, if I'm doing something wrong. Okay, let's try this with a bunch of values. All right. So I'm going to call median index a bunch of different ways. Steal that code up here. Okay. And then I could also find on the medium value. So we're going to have a particular issue with this. I'm going to be going through, I have my entire array, and I'm going to be moving things around. And now that my array is actually changed, and so I can't just keep on calling the same function over and over again because it's actually modifying my original array. But we'll deal with that in a second. Let's write a function to print array, something like that. Well, let's just print it out here. So for in I 0, let's use unsigned. I is less than fm size. No thinking, just doing enough of these for loops. This is going to go from 0 to 1 to 2 to 0 to f. Let's do this. Something like that. It's an unsigned int, so let's put a u, unsigned int, and put spaces around it. And then I want to put I, and then I want to put a find median I. I'm just going to print off my array. All right. So far, hopefully so good. New line in here. And some kind of message at the beginning. Okay. So I'm just going to print out all the elements of my array. In fact, let's do this and we'll make it look pretty. I don't know if this is going to work, by the way. No clue. So I'm going to double check my work. I might put a breakpoint if things aren't working as I expect them to. So let's run my code. Let's see what I get. I may have an infinite loop or something. I don't know. Okay, my array, a find medium is equal to this. At index 0, it's 33. Index 1, it's 17. Index 2, it's 9. 3 is 4. 4 is negative 17. What would I expect? My median function takes the smallest element, negative 17, puts it at the end. It calls calls it again, finds the median element, should be the value 4, puts it at the end. Then finds the smallest value again, the 9, puts it would put it at the end. If I didn't stop before that. Hey, that actually should be working. Right? It seems like it is giving me the right value. So let's actually let's put another printf statement here. Okay, line. The value is a find median at position median 1. Maybe you didn't notice something here. I'm just going to point it out. Here's where asserts are actually useful. This is the actual reason why you would put an assert in here. Because if you try to call median on anything other than a valid input, blow up. Because otherwise you have garbage coming in and you have no idea what the consequences are for your having garbage coming into your function. So a bunch of garbage coming in, you have no idea what to do with it. Your assert is there to go, whoa, you screwed something up. That's what we want. If this thing returns a -1, as in some kind of bad data, something weird happens, I catch it right away versus getting a -1 and then doing all sorts of weird stuff with an invalid index, an invalid position. I can't be a position -1. It doesn't exist. It's not in this series of spaces. I could also have the following. And the assertions, by the way, don't slow down anything. They don't do anything to your computer whatsoever. I have to do the calculation, but oh wait, if I don't do this calculation, it doesn't matter. Like when I run a release build, all those assertions get ripped out of my program. They don't even go to the end user. They're only for you to test your code. Okay, and this is FM size. I also know the value has to be less than FM size, just in case, right? These are sanity checks. All right, now I have this output, and let's see how this goes from here. The median value is 17. Uh-oh, at position 1. Is 17 the value I should be getting? I got these 3 things. I thought my code was right, but the median, it's saying the median value is 17 because it's only looking at these 2 here. Okay. Now I can double check my code again. So what happened here? I incremented each and every time. I incremented how many numbers I was removing, including that last time when I stop. So what I want to do is my min index. Here we go. Right now, I could just do this. I'm removed. Because what I should get, and I could put my breakpoint in here just to make sure that this is actually working as I expect. Okay, I'm at the breakpoint here. Let's have a look at what I have. The min index, the number removed is 2. The size is 5. Oh, this with the number removed was 3 though. So I'd have 2 elements in total, 0, 1. I wasn't including the third one. Now I'm checking the minimum index of the first 3 elements. Those first 3 elements are, well, actually you'll see 33, 17, and 4. So if I step through, the median value is now 2 because now I'm including the one more number and everything should be fine. Median value is 9. Position 2. Median value is 9 at position 2. This is the median value. Yeah, it should be negative 17, 4, 9, 17, 33. And if I don't believe the person, I can do, let's see here. What kind of test would I do? Well, let's do find median 2, and let's be a smartass. 4, 4, 4, 4, and just me trying something out. And maybe I want to find the median index, this whole thing again. Find median 2, 2. This is me just hacking something together. Okay, my median 2, 2, 2. What should the median value be? Uh, Nothing's going to change. It's going to give me the value for. I don't know which one of these indexes it's going to return. I don't care. The median of all these numbers is still going to be 4. So it doesn't matter which index I give. Let's make sure this works. Got to remove that breakpoint. Continue. And here it's for array 2 is 4 at position 0. Fine. That'll do. I could try an array of size 7, all negative values. I could try all sorts of different things. The point is I want to test my code, which is what we're trying to point out with conditionals as well, this homework assignment. Think about where things could go wrong. What's the median of an empty array? Well, it should be, or an array with no elements in it. Well, that actually should be -1. The index is -1. There is no median, right? If you give me certain inputs, what do I expect? And I can test my code that way. Okay, I've been yammering here. So this is just me dealing with an array, me having a bunch of conditionals, me having a while loop, me having a for loop, me not speaking correct English. I'm exploring a bunch of different topics here all in one go. And it might be fast paced, but hopefully not too fast paced for you guys. Are there particular parts that you're still confused by, like ternary operators? It was a great question, Jeanette, by the way. What other things could we look at or we might want to look at? Right? Ternary operators are great for things like the absolute value. Because, well, I just want to make it positive. So if it's negative, make it positive. If it's positive, leave it alone. Let's do a ternary operator for, I do a ternary operator for this. Where is it now? Here, angry text. Maybe. Yeah, I could do that. Yeah. Let's try and do a ternary operator. I'm going to, let me see here. So this is going to be a stupid function, but I'm going to do it anyways. Okay. I'm going to convert letters of the alphabet. Convert letter from lowercase to uppercase. Okay. Turns out that characters, and we're going to see this very, very soon, characters as represented on the computer have to be represented by some kind of number. We use what's called ASCII. It's just some numeric representation per character. And what I don't want to do is figure out I don't want to memorize what the value of lowercase a is. I don't want to memorize what the value of uppercase a is. I know it has a value. They're laid out in such a way that they're contiguous. So lowercase a, lowercase b, lowercase c, all the way up. And at some other point, uppercase a, uppercase b, uppercase c, although all those characters are stuck together in a row. They have their increments of 1. A to C is an increment of 2. There's numeric difference between those two numbers on the computer is 2, right? A to C. So you can do some crazy, quirky things with it. You can just do math essentially on your character. So let's do a ternary operator here. And I'm hoping this is not giving away an answer to an assignment, but you guys showed up. Okay. So I am not original with names. Red val for return value. I have some original character. I need to see if that original character is between, what if it's a tilde? What if it's a semicolon? What if it's a colon? I don't want to change those at all. You give me any character that is not a lowercase letter of the alphabet, leave it alone. Unfortunately, this is assuming English as well. So if it's EX contigu, for example, you leave it alone as well. You would ignore it. Anything that's not A to Z as letters, lowercase a to Z, English language, we're going to leave alone. So let's do this. I need some kind of test to see if something is between A and Z, lowercase a, lowercase z. So what I could do, here's my expression that I'm going to do. I'm going to say original. If the original is greater than or equal to the character A, so I have a character coming in. If it's greater than character A and original is less than or equal to the character Z, I said they were continuous, one after the other. So C, the lowercase value b is in this range. Lowercase value b is in this range. Lowercase value z, still in this range. It's less than or equal to. Lowercase a, in this range, greater than or equal to. So this is just a simple test. Is it between this range, between this number and this number? If it is, then what do I want to do? Okay, I'm going to do some fancy math here. Okay, so let's do put that in there for right now. Otherwise, what do I want to do? I want to keep it the way it is. With me so far. So if it's the proper range, I'm going to convert it to a question mark, at least for now. Otherwise, I'm leaving the character alone. And then I'm going to return red found. Whatever the case is. So the character coming in is uppercase B, and then let's test this out. Why not? Okay. Okay. What was the name of my function? I got to find out. All right. Print and I'm going to make a char called my char1 and call it my char1 convert. Okay. So char my char1 equal to, let's give me a letter of the alphabet. I'll wait for you guys. So just throw me a letter of the alphabet that I can throw in here. Or any character, actually. Well, let's try any character you want. J, perfect. Nice. Okay. And char my char1 convert. I'm going to call this conversion function. My char1. So the letter J goes into this thing. I'm hoping capital J pops out. So this is lowercase j. This should be capital J. That's what I'm hoping. Let's do another one. 2 everywhere because I'm lazy. Okay, so give me not a lowercase letter of the alphabet, although you could give me one of those too, but give me something else. 8, sure. Assuming that's an 8, not a B. It looks like an 8. Okay, and this is character 2, 2. All right, and we'll do one more maybe. So what other, and give you one more. Let's do, what other things could we deal with? We could do a space technically, which shouldn't change anything, but that's the same as testing 8. What other things might we want to try? We might want to try like capital A. I might want to try lowercase a. I might want to try lowercase. Let's try capital Z. Why? Because, you know, it's a kind of weird case, right? That's what we're looking for. The weird cases are what we would love to see. Where can this thing go off the rails? Built, surprising. Okay. I'm missing something. Okay. I'm missing one of my things. There we go. So I'm going to convert these three different characters. Let's see what we have. Over, convert J to question mark. Wait, what? Oh, I didn't change that yet. That's exactly what I should see. Converting 8 to 8, Z to Z. Great. Let's try lowercase z one more of these things because I want another question mark. Or lowercase z or or another question mark. Great. That's what I would expect to see. And if I accidentally forgot that I made this little question mark thing, I see it. My tests remind me, hey, by the way, you forgot to fix that. You forgot to implement that. Okay, I can implement it now. But I've tested what I would expect to see. Now the question is, what could I do here? So what could I do instead of a question mark? Well, I could get a little funky with the math. So what could I do? If the value is sequential, the difference between lowercase c and lowercase a is in this case, because you wanted an example. But that's not the real reason. A ternary operator gives you a short, sweet thing with like one line. If I have an if statement, I have like 4 lines. So let's look at my ternary operator right here. Here is what the function, what the operator looks like with an if and an else. Here's what it looks like with a ternary. It's short, sweet, to the point. It's hard to read. I find it harder to read, but it is. Here's it. Move things around. Oh boy, there we go. Here is some kind of condition. If I have a question mark after it, and that condition, if this condition is true, then I do this. Otherwise, do that. It's the exact same as an if-else statement. It's just shorter and more to the point. And programmers, by almost their definition, are lazy, and they like things that are fairly terse, but still clear. Hence, ternary operator. You can't do much with it. You can do like one change, but it happens so frequently. You never actually have to, in reality, other than us teaching it for 1400, if you go off in an industry and start programming, you don't ever need to do a ternary operator. Technically, you don't need to write a for loop ever. You can always make use a while loop. People will make fun of you if you use a while loop when you don't need to. If you're supposed to use a for loop and you use a while loop, people are like, whoa, buddy, that's dangerous. Ternary operator, some people might say, oh, you could write it as a ternary operator. It's more compact, to the point. So it depends on your philosophy, but it's anything that you can do with ternary operator, you can do with one of these with an if and an else. It's just short, and people want an example. So if this is true, then I will do this. Otherwise, I will do this. This thing here we'll get to very, very soon. I'm just going to tell you what we're going to do. The difference between lowercase a and lowercase c is 2. A, B, well, A, B, C, 2. Difference between lowercase a and lowercase a is 0. It's the same thing. Lowercase d, that would be my Google Home somehow responding, which I didn't mean it to. Anyways, if I have a ternary operator, if I have a D, it's 3. That would presumably be 25 difference. So I can get that difference. Capital C and capital A has a difference of 2 as well. So what I could do is take my character, subtract lowercase a, add uppercase a, and the math should work out for me. I wouldn't expect you to just naturally come up with this off the top of your head, but this is what you could do. So I'm going to take my original character. I'm going to add uppercase A, subtract lowercase a, and that should be, we're going to find out, should be my value. J, capital Z, capital J. Hey, it worked. I would try a whole bunch of cases. But I don't have to write all my code all at once. I can put little things, just a reminder or little stubbies. I can write a function and just put return 0 in it just to give what it looks like and then fill it in later. I can do IOUs for myself. I don't write, when I'm writing an English essay, I don't write the entire essay start to finish all in one go. I do a chunk. I do this part. I do this part. I do this section. I don't work on the entire, you can't write an entire novel at once. You either do an outline or you do a chapter or you do part of a chapter or you refine some part of it, but you can't do everything at once. So you can get, if I want just the outlines, I can write all my functions. The functions don't do anything and then fill them in one after the other. Do a little bit at a time, code, test, move on to the next part. All right. I'm conscious of time because I know we started 11:35, and if you guys want more questions, I'm more than happy to answer more questions. If you want to go, head on out. I've recorded all of this anyways. One other thing I was going to play with, if you didn't mind doing it, which was I'm going to put I'm going to make an array of characters. We're going to find out how that works. And then the original plan was I'm going to make an array of characters and just convert every single one of the characters to uppercase. I think that's actually an assignment question, so maybe I should hold off on that. I think I'd rather ask you guys what you want to do or what you want to work on. Yeah. What's the next approach? Is there something that you really are still confused by? Do you understand why an if statement works? Switch statements. If you want a switch statement, I can give you a switch statement. Sure. Let's do this. So you're going to give me a character to check. Plus guide. I'm going to even include modular arithmetic, some kind of math operator. Okay. And this thing is, yeah, let's do it that way. Okay. So here's one thing I could do. What other things could I have done for this? Let's do it this way. Okay. So here's my switch operator. My switch operator has to take something that's enumerated, something that I can put a number to it. I think there's some fancy new ways of doing it, but I have not even figured that one out myself. So normally it's I think on the assignment, I said, hey, for 0 bonus points, calculate whether you get an A or B or C or where the letter grade demarcation points are. I think that's actually for A8, but worth 0 points. So what I could do is get a grade and figure out if it's, or maybe I'm looking at 50 or 40 or 30, like a number like that, because I'm figuring out Roman numerals. I have an example of that, I think, as a switch statement in the assignment as well right now. So here's what I'm going to do. I'm going to take the thing I'm looking for. This is what I'm going to be checking to see if it's equal to. Thing to check, the character to check. It's stored as a number, so I can do a switch statement on. I can't use a string. That's just not a single number. I can put an integer. I can't put a double. It's not an integer. It's not a whole number. but I can put a character, for example. It's sort of represented as a whole number. And then I have different cases. And so what I might have is if it's equal to this, return 1. Case return 1. What other things am I missing? Oh, plus. Okay. And if there was something I missed left up, I could just add this particular condition. Okay. And if none of those occur, I like having this anyways. I can have a default. If I don't have a default, I still go flying all the way through. Return 0. So 1 for true, 0 for false. So if you give me a multiply symbol, if you give a subtraction, a division, or plus, or a remainder, I say true. Otherwise, I say false. As in, you give me any character other than those, it's not a mathematical operator. Okay. Here's the little gotcha in here. And I'll throw the gotcha. Let's do it. Let's do it this way. I'm going to just call my function. I'm going to need to put that up here. And I'm just going to call this function a bunch. Division and letter A. So I would expect a math. I'm just going to save the value just in case I need to see it later. Why not? All right. But what I really want to see is what happens if I call this function. What should happen? The operator, the character is passed in. I check to see, and I look at all these different cases. If toCheck is equal to star, I will return 1. If toCheck is equal to dash, I will return 1. Oh, wait, I commented out that line. So what's going to happen? That's the weird thing about switch statements. So let's do this. Printf and one more time. All right. Let's look at what my code is, where my code is. I'm going to go back up one in the stack, and is operator initially is equal to true. So multiplies is true, is an operator. Great. Here I am. I went with the operator that I'm looking at is the dash. I get to the dash, and what happens? The comment line is the line is commented out, and I keep going in the switch statement, and I return here. Once I go into one of these cases, I will keep on doing all the instructions. It's weird. I'll keep on doing all the instructions down until I break or return. This is where So I went in here, and then I'm going to do every statement until I get to a return or until I get to a break. Breaks are normally the way to do it. And so I'll go in here and return. Okay, that's weird. Let's try it more. We're in the third case, the division. I return 1. Great. And then one more, and then I'm done. Let's look at what my output says. Uh, wait a second. Shouldn't I have this printf statement? There is an example way up here, right here. I have something that's not an operator. The default, I go through the default, I go to the end. Why is it that I should get to the end if none of those things is true, right? None of these switch statements are true. So why am I not calling this printf statement at the end? Because the default returns something as well. And as soon as I say return, I'm out. I'm done. I can't do anything else. There's no other steps. As soon as you see the word return, I'm done with that function. So at that line, with that default, I got to the return 0, and I was done with that function. So 0. Here's what happens if I remove the default. No. Got rid of the default. I'm in my breakpoints a couple of times. Boom. And here's what I have. End of switch statement. Because I didn't hit the default, because I didn't return there, I get finally to the end of the line. See this output, then I return 0, as in it is not. So switch statements are, imagine it catches, your data comes in and it goes down until it catches to one of these conditions, and then it follows all the instructions afterwards until it gets to a return or a break. Actually, let's do this. Put that in there, but instead the return 0, break. And notice I put my default right back in here. But because I did a break instead of a return gets me out of the function. A break says, get me out of the switch statement or the if statement or the for loop or whatever I'm in. It breaks me out of whatever curly braces I'm in. So a break pops me out of this switch statement, but not out of the function. And then I do the printf statement. That's switch statements. You don't need switch statements. They're just nice for looking at things, especially if I have a certain set of numbers. When we do assignment 7, it's the Chinese zodiac. There's only 12 Chinese zodiac animals. So you can have a switch statement and go and check each one of the animals. There's 12 conditions, not an if and else statement. It's faster, better, cleaner to use a switch statement with 12 different branches. That's the way to do it, and have a default for one of the zodiac animals. So no matter what you give me, I'll give you a zodiac animal. That hopefully helped. Other questions? This time is for you guys. So if there's other questions you want, or if there's something that's confusing you, speak now. I also know there's a bunch of people trying to work like 3 weeks in advance, so things are sort of splintering a little bit. Don't be too freaked out by that, but it means I'm a little scatterbrained because I'm worrying about the next 3 assignments. Return different things using the switch statement. But ultimately, yeah, you can return different things altogether, but ultimately it's determined by the return value for your function. If your function says it returns an integer and you try and return like a string of characters, like a whole bunch of characters or a struct or something like that, it will yell at you. So this is going to return this. Let's see if I can break it. I don't think I'm going to be able to break it, but the reason is because A is also can be considered a symbol. But let's try this. Hello. Okay. Can I return a string? Uh, oh, hell no, I can't, because it says the return value is an integer, and you're trying to return something that is not cannot be interpreted as an integer. It's a whole bunch of characters, one after the other, and therefore it yells at you. So as long as it adheres to the return, what kind of return value you're going to give, then you're allowed to put whatever you can return whatever you want. Other questions? I know it's supposed to be an hour, but I also go long because I think, if you guys have questions, I'm more than happy to answer them. No, you can't return a printf statement. Return printf statements. Oh, actually, let's look at a printf statement. It does return an integer, so technically you could, but the question is, what does a printf statement return? It's not the actual statement itself that's returning. I do believe it's the number of characters that are being output. I think you can always look at that. So it would be however many characters this whole thing is. That's what the printf statement would return. And so it returns an integer. You could return it, but it wouldn't make sense. In this case, we're saying true or false, 1 or 0. One or zero, true or false. It would be, let's say, a Chinese zodiac animal. It might be we're going to be looking at enumerated data type. So if I said month, so let's say, oh, let's do that. Uh, you'll have to hold, this is from what we did with the Super Bowl printer. Um, Next month, you give me some kind of unsigned and month num. You give me some month number, and I'm going to say what month it is as a string. Okay. Okay. Case one. Actually, I could go case. Let's case one. I don't know if you want to have January start at 1 or January start at 0. That's the question. So February, we're going to make case 2. I'm going to cut it short for a second here. But I would do all of the months. And at the end, I return that. Or I leave off the default and just say return December all the way out here. Either one. It's the same thing if I return it into the default or return it outside here. It's going to be the same thing. Okay. So let's do this. A bunch of other stuff goes here. So if I call text month, what do I output? Let's do one of those. And I'm going to need text month to be, sorry. There you go. I need to know about it. Text month. Okay. And why don't we say 0? And then we'll put it in the printf statement. Um, that should do. A 0 goes in, it goes through the switch statement, it returns a string, a character string like we did with the Super Bowl printer, and then it outputs it to the, it's going to be part of this printf statement. So month 0 is the month of December, according to this. If I change it up, and so let's change it up and say 12. It'll be December. And if I change it to 13, it's gonna be December again. It'll still be December. Anything that is not 1 to 11 or the other examples, it's that by default, I get December in this case. And if I wanted to make 13 to be January again, modular arithmetic, I just mod it, do that percentage by 12, and it goes right back to 1 again. That answer your question, hopefully? That's 2 different switch statements as well here. Okay, we're really going long. Keep me informed if there's anything that comes up. I'm going to post this as soon as I can in the synchronous lecture playlist. If there's anything that you notice that's off or you have other questions about the assignment, please let me know, okay? All right, thanks everyone. Thanks for listening, and I will hopefully talk to you soon. Let's close this off.